So for these first four calipers that I asked you to read, remember the first thing we have to figure out is if this is metric or standard. These say it right on the dial if you can see it. 0.01 millimeters, so these are read in millimeters. Now remember, the tricky part about the metric caliper is that is not 1. What does that really stand for? 10. So here's our reference edge. That's where we're reading that main scale. That's 10, 15, 16, 17, 18, 19. So that's 19 whole millimeters. And I don't know what just happened there. 19 whole millimeters. Point. What does it say on the dial? 48. So 19.48 millimeters. So this second one, that's 30. 1, 2, 3. So 33. Point, the dial says 56. So 33.56 millimeters. How about this one down here, number 33? 13.66. Perfect. This is 10, 11, 12, 13.66. 34? 38.52. Perfect. Well, then we're going to move down a bit. Now you can probably guess that these are not metric anymore. These are inches. That says, again, if you can see it, 0.01 inches is what that says. I'm going to give you guys a minute or so to read those four, and then we'll talk about them. So for the first one, reading in whole inches, this is 1 whole inch, point, that's the tenths, 2, and then the dial says 62, so 1.262 inches. Over here on the second one, how many whole inches? 0. Point, past the 7, and then 77, so 0.777 inches. I'll put these up so we can see them a little better. Oops, that's the wrong direction. Okay, so number 39 here, how many whole inches? 2 whole inches, 2.353, so 2.353 inches. 40. 1.5 and then 69, so 69. Any questions on reading those calipers? Okay. Well, today then we're moving on to reading micrometers. Micrometers are kind of like a big C-clamp. Don't use them as that, it's not good for them, no. Look something like this. That's what our micrometer looks like. We have the jaw or the arm of the micrometer up here. This is stationary here. This part moves in and out as we turn the part out here. This out here has 2 pieces to it. There's the barrel. Oh, we can do this. There's the barrel, which is this part here. That stays stationary. That's going to lock onto the jaw, onto the arm. And then the thimble is this part here. That's the part that actually spins. As that spins, it slides in and out on the barrel. It moves in and out on the barrel. And as it spins, it moves this piece in and out as well. So there are going to be 2 measurements we need to take here. We get part of our measurement. Actually, technically, there's 3 measurements we should take. Most of these are labeled 0 to 1 inch, if I'm looking at an inch micrometer here. That 0 to 1 inch means that this will never measure anything larger than an inch. Now there are going to be some that say 1 to 2 inches and 2 to 3 inches, and we'll talk about that in a little bit. This thimble, when we turn it, it moves in and out. One full turn is a 40th of an inch. So you have to make 40 complete turns to move an inch. Because of that, it's very slow to move it in and out. Because of that, they almost never have them with more than 1 inch of travel in them. So this will almost never be more than an inch. I have seen some that go 2 inches, but they're extremely slow. In fact, one of them I saw actually had a crank on it to turn it faster. Most of the time, they only have 1 inch of travel because of that slow movement. Now, like I said, this one is a 0-1 inch, the way I have it labeled there, which means it would close tight here, and it would open up as far as 1 inch. If I had one that was labeled 1 to 2 inch, what that means is when it's completely closed, there's still a 1 inch gap here. And if it were totally open, it opens as far as 2 inches. So it's only able to measure things that are larger than 1 inch and smaller than 2 inches. And then, of course, they have 2 to 3 inch, 3 to 4 inch, and so on. We take the first part of our reading off of the barrel. We read it at the edge of the thimble. Now, remember, we said this is 0 to 1 inch, so these numbers are not whole inches. Those are tenths of an inch. So this here is 0.3 inches. Now, we looked at that vernier caliper just a little bit yesterday. That vernier caliper had quarter marks, the 3 marks in between the tenths. All micrometers have those quarter marks. All inch micrometers have those quarter marks. What that is saying is this is 25 thousandths, 50 thousandths, and 75 thousandths. So here we have passed the 3 tenths. We have passed one of those quarter marks. That is 25 thousandths. So that's 0.3 and then 25. That's what we read off of the barrel. Then we read the thimble. The thimble gets read where it lines up with this axis of the barrel. Right now you can see that's a 15. That's 15 thousandths. You would add that up, you get 340 thousandths of an inch, just as they did over here. So let's practice some of these. I apologize for being a little bit blurry, but that's the price we pay to make them large enough to see. How many whole inches? Trick question, 0. How many tenths? It is 2 tenths. Any quarters? Yes, 1. So that would be 225. Then we would add the 15 to it because that's what lines up. So that's 0.240 inches. So here, whole inches, 0, yep. Can't catch you twice in a row. Tenths, 4. Now, here's the question. We see the edge of this line here. We're either just about to get to it or we've just passed it. How do we tell? We look at this. If we're not quite to 0, we haven't made it to it yet. We've just passed 0, we've just passed it. Right now we're dead on 0, which means we're exactly on it. That is the 25 thousandths, or the first quarter mark. So that's 425. And then we'd add 0 to it, so it's just 425. So 0.425. So here, 0 whole inches. Now we're obviously past the 7. Have we made it to the 8? Well, once again, we're exactly on 0 here, so that means we're at one of the lines, so we must be exactly at 8 tenths, 0.8. Do we need these zeros on the end? Yes, we do. So that whoever is reading that measurement knows that we really did measure to the thousandths of an inch. and it happened to come out closest to 0.8 to the nearest thousandth. Okay, let's make them a little more interesting here. This one, how many tenths? So 0.9, and then 25, 50, 75. So 0.975. And then we read the thimble at what? 5 thousandths, 0.005. So we add that up, that's 0.980 inches. How about this one? How many tenths? Have we made it to the 6? No, this is 20. This would be 24. We have not quite made it back to 0 yet, which means we're not quite to the 6. So that is 0.5. Quarters. 75, good. 25, 50, 75. So that is 0.575. And then on the thimble, 24 thousandths. So that is 0.599 inches. How about this one? Tell me where to start. 0.6. Careful. 25. We've just passed the 0, so that means we did just pass that mark. Then on the thimble, 1,000th. So that adds up to 0.626 inches. How about this one? Point 4. 25, yep. 9 thousandths. So that is 0.434 inches. Now in this one, I'll say it's labeled 2 inch to 3 inch. So what that means is our measurement starts out as 2 whole inches. Then we read how many tenths? 7, 25 because we're past 1/4 mark. Then off the thimble, 22 thousandths. We add that up. It's 2.747 inches. Now remember, the 2, that only comes from the fact that I told you it was a 2 to 3 micrometer. I'm going to read this one in your notes. I'll give you about 20 seconds here, and then we'll talk about it. So this is point what? 898. Good. We got 0.875 here. 0.8, 25, 50, 75, and 23 on the thimble. Is 0.898 inches. Try this one quick. Is 0.3, 25, and that is 13.338. There it is. Inches. Now the micrometer, because of its structure, can only measure outside dimensions, outside diameters, outside dimensions, with a standard micrometer. Or the caliper, if you remember from yesterday, had 4 different ways it can measure. It can measure outside, inside, step up, or depth. To measure inside dimensions or depths, we do have an inside micrometer. Now, the inside micrometer, you'll notice, first of all, it has this on it. That is an extension. That 3 to 4 inch extension means that any measurement I take with it's going to start at 3 inches. What's that? Then we read the main scale the same as we always have. That is 0.2, 25. And then we read the thimble. What's lining up on the thimble right now? 20, so it's 20 thousandths. This is 3.245 inches is the depth that's reading. Now this one you'll see looks similar, but slightly different. I'm going to flash back. What do you see that's different between these two? It says 3 to 4 inch, but there's this piece here that isn't there, is there? That is a 1/2 inch extension. On an inside micrometer, in order to keep them smaller and shorter, there's only a 1/2 inch of travel. This would only go up to 0.5 here. So this is saying this is 3 inches and a half. So this one starts out at 3.5 before we start reading the barrel and the thimble. So that means we're going to have to do a little bit more addition here. What does my barrel read? $3.25? $3.25? What's my thimble read? 12 thousandths, so 0.012. So then I add up, I've got 7, 3, 8, 3. So 3.837 inches. Any questions? So on this one, where do I start? 2 whole inches. Yep, 0.350. Got 3.2550. Then on the thimble, that's 21, 2, 3, 4. 24 thousandths. 2.374 inches. How about this one? Where do I start? The 3, and that's an additional 0.5. Then what? 0.1, and it is just 25 again. Off the barrel, 10. So, oops, that should be a 6. 3.635 inches is what that's reading. Have you try this one on your own. We'll talk about it in about 20 seconds. So where do we start? For 0.5, yes, this is the 0.5 because of the 1/2 inch, yep. Then what? 475, very good. This is the 0.4, 25, 50, 75. And then what? 0.24, 24 thousandths. So that's 999.4. So 4.999 inches. This one here is a little bit different. There's a good reason for that. First thing we'll notice that's different. Instead of being labeled in ones, it's labeled in fives. Second is, you'll notice this is 45. Instead of going from 0 and 25 is back at 0 again, this one goes from 0 around to 50 would be back at 0 again. This is metric. This is in millimeters. You'll notice here, this is 15 millimeters. This would be 16, 17, 18, 19, 20. But you'll notice there's these additional marks in the middle here. Those are the half marks. So this is 15, 15 and a half, 16, 16 and a half, 17, technically 17.5, 18, 18.5, and so on. So as I'm reading this one, this mark here is the 21 millimeter. Have I passed it? Yes, because I've just passed 0. There's 21 whole millimeters. Then what do we read on the thimble? 0.5. Very good. Because that is in hundredths of a millimeter. Even though that just says 5, it's 0.05. It's 5 hundredths millimeters. How about this one? Well, it's 15, 16, 17, 18.5. So 18.5. Yes, and then plus 0.45. So that's 18.95 millimeters. How about this one? 5, 6, 7, 8 and a half. But this is at 0 here. So that's telling us we're clearly past the 8 and a half. We're not right on 8 and a half. So we have to be right on 9 is what that's telling us. And yes, we do have to write that as 9.00 millimeters because we are within 100th of a millimeter. How about here? Yeah, 10, 11, 12, 13, 14. 0.03, yes. This one? $17.5, right? Plus, looks like 35, right? So 17.85 millimeters. Any questions? I have no idea which one this is going to be, but we're going to try it. Quiz. Whatever the quiz. Oh, come on now. A little bit. There we go. So let's do that's not the one I want either. How much you want to bet? I'm going to check 4 of them. They're all going to be the quizzes. Oh, there's one I'm looking for. Okay. First of all, metric or standard? How can you tell it's metric? It goes up to 45 and back to 50 here before it hits 0. Also, oops, come on. If I roll this out, you can see why they don't have a lot of travel. It's just as slow on a real one. It all depends on screen resolution. So here, I am currently at Have I made it to the 7? No. It's 6.5, right? I probably should do this so you can't read the little thing down there. This is 6.5, and then this is between 44 and 45. I go to whichever one it's closer to. It's closer to the 45, right? So 6.5 plus 45 is 6.95. How about here? 7.5 plus, I'm between 8 and 9, closer to the 8. On your standard micrometer, whether it's an inch or a millimeter, by standard I mean it doesn't have the extra scale that we're going to see in a little bit. You can go to the nearest marking on the thimble. So I'll read the barrel here. This is a little bit less obvious. 6, 7, 8, 9, right? 0.0. And then this is between 21 and 22. It's closer to 22. So that's 9.22. Well, they're saying 9.217. I'll explain why. This applet's actually designed to be vernier. It has an extra digit on it. You just can't see it on this application. On one without that extra scale, which is what we're going to be using pretty much, you go to the nearest marking here on the thimble. We can, however, run into ones maybe we can run into them. Okay, here's what I'm talking about. You'll notice, I know they've got a little cheat on here, but this is still millimeters because it still goes 45, so it goes up to 50 before it wraps back to 0. And it is still labeled. I can open it up far enough. You can see the barrel is still labeled in 5s. But you see these extra numbers up here. What that is if I look at this, you can see right here, I am between the 3 and the 4, aren't I? Well, this is a vernier scale that tells me how far I am between the 3 and the 4. Right now, this is 5, 6.5, right? 6.5 plus, we will always go, when there's this extra scale, we'll always go to the smaller one. Even though right now, it looks like we might be slightly closer to the 4, we always go down. It's going to be the 3. So 6.53, and this is telling us how far we are. This lines up, the vernier scale actually lines up at 5, doesn't it? That's telling me that we're actually exactly halfway between 3 and 4. That's actually 3.5 is what that's saying. So this is 6.535. That extra digit goes on the end. So this is, move that cheat down at the bottom. 7, right? Here we are between 24 and or 26 and 27. Doesn't matter which one we're closest to. We'll go to the smaller one, the 26. So it's 7.26. And then this lines up as a 2. That's just the last digit on the end. 7.262. So if you have that extra scale, that vernier scale, and you're going to be using it, you always have to go to the smaller number, and then you tack that vernier digit onto the top of it. So here, this is 7. Have we made it to 7.5? No. So this is 7 point, we're between 45 and 46. Which one are we going to use? 45. Even though we're way closer to the 46, we have to use the 45 because we're using the vernier scale here. So this is 7.45 plus, now this thing cheats and it gives you a little highlighted line which one lines up. It's the 8. So 7.458 is what that's saying. We can have similar things on the inch micrometer. First of all, of course, how do we know that this is an inch? With what we can see here. Goes up to 20, then back to 25 is 0, yes. If I opened her up, oops, without flopping it off the screen, you can see it's numbered in ones, not fives. Now, this is 0.325, right? 0.325. This is between 13 and 14. Even though it's closer to the 14, if this vernier scale wasn't here, we'd go with the 14 because it's closer. Since the vernier scale is here, we always go to the smaller one, the 13, and then an 8. So 325 plus 13 is 338 plus 8, so 0.3388. Does that make any sense? Well, that's kind of a mouthful to keep in your head. So this is 0.375 plus 13, so 388, 4. That's just the vernier scale, just the extra digit that goes on the very end. Okay, I'm not going to pound those into you anymore. You guys get the picture. The key is when I switch between I can get the right ones here. There's what I want. Like I said, the vernier, if you guys do well on the first quiz, which might be tomorrow, we won't have vernier on any of the quizzes. If we have to go back, and they said 4 out of 5 classes, I usually have to go back and do a little bit more with calipers and micrometers just because that's the nature of it. If I have to go back and spend more time on them, then we do put the vernier on there, just so you know. So reading this one right here, what's this going to read? .250, yep, plus 14. That's kind of relaxing. Going to put me to sleep. So this is 0.264, right? How about this one over here? Sorry, I didn't mean to make fun of your ringtone. It really would put me to sleep after a little while. 7.5, and then plus 42, so 7.92. How about now? Go ahead. 9.17, 17 there. 9.17. How about this one? .35. Oh. And this is closer to the 11, so I'll put 11 on as 0.361. So that's the biggest thing people struggle with, again, just like with the calipers, is keeping the decimal places consistent. Again, notice they use the comma for the decimal point here. That's that European standard. So what I'm going to do is I'm going to turn you guys loose. Did you guys have any questions off the packet from yesterday, off those caliper packets? Any of them you couldn't get? Just wanted you to do them for practice, yep. I see a lot of them were right off the PowerPoint, if you saw. Okay, so then, in your book, there actually are micrometers in your book. On page 183, exercise 4.4a, and on page 186, exercise 4.4b, are reading micrometers. Tomorrow we are scheduled to do our micrometer and caliper quiz, just so you know.